There's a famous quote from Bjorn Stroop, the creator of C++. He said there's only two kinds of languages, the ones that people complain about and the ones that nobody uses. Developers love to hate JavaScript. In fact, it's been like an online pastime for years, and you'll see these articles, or maybe you've heard podcasts where people will dunk on JavaScript and say, ha ha ha, you can like multiply an array times an array and get zero, or something silly. You can add a string and a number and then get a string. Ha 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 ha. If you're one of those people, you probably won't like this show, but I can tell you this won't be one of those useless shows about every obscure feature of JavaScript that you need to know that you'll never actually use. I want to just share three concepts that genuinely blew my mind as a JavaScript developer and have some useful and practical application and how you can understand these things and then apply them into your own code base because it may really help you out. First feature on the list, web workers. So let's pretend that your team wants to create this feature for their AI native cloud first platform that's disrupting the burrito industry or whatever, right? A user uploads an image of a burrito, and they can edit this image by adjusting the brightness or adding custom burrito filters to this burrito. All this is going to happen in the browser. Browsers are increasingly doing a lot of work, right? Browsers are fast, our machines are getting faster, the networks are getting faster. We're adding more and more and more to the browser, right? So this kind of feature isn't that far-fetched to assume could be a realistic feature. So all this is happening in the browser. And then you notice the UI just kind of locks up, right? If you're doing lots of transformations across a ton of different bits and bytes in a picture or whatever, your browser is going to say, I can't do all that, right? The page might stutter. It feels kind of broken for a few seconds. Users can't click around. Not terrible, but not ideal, right? And the reason that's happening is because the work of transforming the image is happening on the main thread. JavaScript is single threaded. You can execute work in one place within the browser, right? You don't have multiple threads where you can run work in parallel. You have browser APIs that help you do asynchronous types of things, but you can't truly run a whole stream of work somewhere else, except if you use a web worker. So web workers let you move work off of the main thread entirely, and instead of blocking the UI, you can send that work somewhere else, and then you can get the result back. You can pass messages between the browser and the web worker, right? A really simple example might be spinning up a web worker by saying new worker and then saying the name of that worker file. Then you could post a message where that web worker will take that message, will take the image or the CSV file or something computationally expensive that you want to do, and then do that stuff on it. And then you can send a message back to the main thread, to the browser saying, hey, I'm done with that thing. You're like, cool, right? Because users don't expect an image to be transformed maybe immediately. Maybe we're just doing something computationally expensive and we don't want the main thread to be choked up. So now you're not sharing memory, you're sending messages to keep these things in sync and your UI can keep working. This applies to image optimization, CSV parsing, maybe analytics, anything that's heavy, right? That may be blocking a user from taking other actions on the screen. Even burrito image optimizations. So using web workers lets you operate on another thread without blocking other functionality entirely. Next feature on the list, generator functions. This doesn't get as much attention as I would think. Generator functions are super useful and they have this weird kind of funky looking syntax. It looks kind of like you wrote a function the wrong way, like you fat fingered a function as you were typing it in. And they let you pause execution and resume execution of a function wherever you left off. So it's written like this, function and then an asterisk after the function keyword. It looks just like a little ridiculous. It looks really cool to me. So you have like function, asterisk, counter or something like that. And then you'll have a yield statement, like yield 1, yield 2, yield 3. And so every time you invoke that function, that generator function, you can say counter.next. Counter.next, and it will yield 1, then it will yield 2, then it will yield 3, and then you can keep going until it basically runs out of yield statements. And you could just have this going infinitely if you want. You could say while true, yield whatever. This might sound like a bit of a parlor trick until you realize this actually has a pretty cool utility. Because they can remember where they left off, the variables don't reset. They live inside the function in between the calls, and you control when the next step happens. So a really practical example is API pagination. If you're using the movie database, for example, and you want to go page 1, page 2, page 3 to like page 1,000, right? You can simply use a generator function that could maintain the state of which page you're currently on. And every time you do next, you could do another API call to that new page. That is actually a really useful way to use generator functions that you don't really see documented too often, but I have actually used it for that purpose. I've also used it for generating fake data when I wanted to make a line chart with smooth animations. We had this line chart where we needed to see how it reacted or how it responded to having a lot of data generated. And so we used generator functions in order to create data every second that would like add to this massive list of data for a line chart. That was the way I've actually used it. And I've used it with APIs that have pagination. So that way we can go like if a user clicks next, we'll just go to the next page of that data and we'll call this generator function. And lastly, web components. I'm actually using these at work right now. We're making a micro front end that we're going to bake into a Rails app. And I'm using React, Vite, some frameworks that I'm not super familiar with, and building a micro front end. And we're going to use web components to expose this micro front end. Web components are almost like React.js baked into your browser, kind of, right? Like with web components, you can define your own HTML elements and use them anywhere that you can use HTML elements, the browser, right? You can build a custom HTML tag. And it looks a little something like this, or you can kind of visualize it. I'm going to go through the code in words, which is always a little weird, but you can get the transcript from this episode or just dump this into a code editor or OpenAI or whatever AI tool you're using, and then you can get back a good example. So you may have something like class, my counter, extends HTML element. And then you'll have this connected callback method. And in that connected callback method, you can access the inner HTML, and then you can have like a button or a React component or whatever, right? And then you'd say custom elements dot define my counter or whatever you want to call it. And then you'd pass in that class that you created. Anyway, that's not so important. We don't need to get into the minutia of how to actually write the code in an audio episode. That's not super useful. But now you have this custom tag. And the interesting thing or the cool thing, it's just like a static component that can live really anywhere. And you could have functionality like click events. You could do API calls. You could do all sorts of really, really cool stuff with this little component here. And you can pass data to it through data attributes. You can use it for micro front ends like I'm doing at work. But you can make a custom tag that is deliverable as an HTML component, and you could package up a React component or a React page and expose it like this and add it to some HTML somewhere. Boom, you have something pretty cool. Or maybe your team, for whatever reason, can't use React and you need to define a custom web component. This lets you opt in to component architecture without a framework. It's really kind of useful and pretty cool, and it's not really that talked about, but it's really well documented. If you go to MDN Docs or just look this up with some AI tool, it'll give you all the information you need and how to build them. It's really, really simple. Now, here's my kind of hot take on all this stuff and why I'm still so bullish on learning to code, because I think about this a lot. I'm thinking, do you need to know any of this stuff? It turns out, I think it's even more important to know some of these obscure things sometimes. Because if you think about how AI models are trained, right? They're trained on the entire body of the internet, correct? And what you're going to see is a distribution of that body of work. In the middle is where most developers will fall. And in the middle is where most of what we do as developers lies, right? We make the same things kind of over and over and over and over and over. And then on either end of these distributions, you see weird things that are just outside of the normal flow, right? I would argue that the three things I just mentioned are a bit outside of that normal distribution of work that people normally do. So more important than even knowing how to use these is just knowing that it exists. Because when you know that it exists, you have a larger tool belt, right? You just have more tools at your disposal to do cool stuff that you might not otherwise know how to do. So this is important. It's still important not only to learn how to code, but to then learn what kind of different patterns and solutions exist to solve common problems. And some of this you're going to find in books. Some of this you're going to find on shows like this. And some of this you're just going to learn through trial and error and looking in old code bases or talking with your coworkers. I don't see a substitute for this. In fact, there are companies right now that are actually trying to generate more data to get better data to further try to automate software engineering. But I think that's going to be a losing game because there's simply not that much data we can produce as humans, and synthetic data apparently isn't that good. So right now, we have a distribution of data that is available through AI tools that is pretty average. So you get fairly average code. Nothing wrong with that whatsoever. The moment, though, that you need to step out of that, you as a developer have to know, hey, here's some different ways I can approach this, and here's how I can put on my thinking cap and tell the AI tool what to do. So there's no world that I see in the future, even in the long-term future, where you don't need to have some sort of competence with writing code. Oddly enough, you're going to have to learn how to code the old-fashioned way and then never code in that old-fashioned way ever again. Because if you keep just prompting AI tools, you'll probably get a slightly better version of the same solution. And I'm just going to reiterate that knowing this stuff exists doesn't necessarily make you smarter, but maybe it does, I don't know, but it does give you more options. Anyway, if you're out there learning how to code, or if you're just at the beginning of your journey, or maybe even further along in your journey as a software developer, I do think that there's still a lot of utility in what we know, and having this tribal knowledge and also reading books and going old school is really going to be a superpower in the future, as more and more and more people, the majority of people, I hate to say, are going to default to whatever ChatGPT says, and having some of your own brain power, even a little bit nowadays, can go a long, long way. That is my bet, my strong bet for the near future and the long-term future. Anyways, I hope you found that helpful. I would encourage you to take these concepts, try to apply them in a code sandbox or in your editor somewhere, and just see if you can make them work. That's going to be much more helpful than just hearing me yap about them online. And hopefully they kind of exposed you to some cool new ways of doing stuff. But anyway, hope that's helpful. See you around. If you have suggestions for a show that you'd like me to do, please let me know. You can find me on LinkedIn. You can also email me at brian@parsity.io. And if you want more information on the programs that we have for learning AI, learning JavaScript, or becoming a full stack software engineer, we have something for you. Just go to parsity.io. And if you have questions, told you where to hit me up. Find me online if you want. And I'm always happy to answer questions or chat. See you around.